I have decided to do Prompt B, which talks about gene mutations that cause throat cancer in dragons. Throat cancer in dragons has been linked back to genes X, Y, and Z. Here is what we know about these genes. Benign tumors require both alleles in gene X to have mutations. Malignant tumors require both gene X alleles and one allele of gene Y to have mutations. Metastatic tumors require both gene X alleles and one allele of gene Y, and also one allele of gene Z to have mutations. One last detail, gene X is the only one that a mutation can be inherited. Here's a chart laid out with all of the gene mutation descriptions I just listed out. The X's in certain boxes represent the mutations needed for that specific tumor to be present. A set of boxes represents two alleles for that particular gene. Let's see some examples of gene mutations in 3 dragons. The green dragon has a mutation in both X alleles and one Y allele. This corresponds to the dragon having a malignant tumor. The red dragon has a mutation in one Y allele and one Z allele. This corresponds to the dragon not having a tumor at all. There must always be a mutation in both X alleles for a tumor to even be a possibility with this particular throat cancer. The blue dragon has a mutation in both X alleles, one Y allele, and one Z allele. This corresponds to the dragon having a metastatic tumor. Here are the differences between tumor suppressors and proto-oncogenes. Normally, tumor suppressors prevent bad cell proliferation, and proto-oncogenes allow for normal cell proliferation. However, when the functions are disrupted, bad outcomes may result. If a tumor suppressor gene loses its function, this can mean that nothing is stopping the bad cells from multiplying. A tumor suppressor losing its function in suppressing tumors will essentially enable a tumor to grow. Mutations in both copies of the tumor suppressor gene must be present in order for a loss of function to take place. If a proto-oncogene gains more function, then this can result in excessive growth of cells. A mutation only needs to be present in one copy of the proto-oncogene for this gain of function to occur. Let's see what these genes are considered. Gene X is a tumor suppressor. Tumor suppressors require mutations to occur in both alleles of the gene for a tumor to appear. For every tumor that involves gene X, both X alleles must have mutations. Gene X is also the only one that a mutation can be inherited. This is only possible for tumor suppressors, not proto-oncogenes. Gene Y is a proto-oncogene. Proto-oncogenes require a mutation to occur in only one of the alleles of the gene for a tumor to appear. Any tumor that involves gene Y, only one of the alleles needs a mutation. Gene Z is also a proto-oncogene. Any tumor that involves gene Z, only one of the alleles needs a mutation. Sources are listed in the description.